How can we solve problems involving velocity time graph? On the board here, I've got this question we're going to solve. So let's see. A car starting from rest accelerates uniformly and attains a speed of 80 meters per second in 30 seconds. It maintains this steady speed for another 30 seconds. It then slows down uniformly until it comes to rest in the next 40 seconds. A. Sketch the velocity time graph of the motion. B. From the graph, obtain the uniform acceleration during the first stage of the journey. C. The retardation during the last stage of the journey. D. How long did the car travel altogether? So the first question we're going to look at here is to sketch the velocity time graph. Alright, so to sketch the velocity time graph is just a simple one. You draw your vertical, you draw your horizontal, okay? So we're going to have something like this. This is my velocity, the unit is meter per second, and then this is my time, it's in seconds. So let us look at the motion of the car. The car started from rest, so here it's going to be 0, here it's going to be 0 from rest. So it's going to be 0, and then what happened to it? It's now moved with a speed up to 80 meters per second. So it accelerates uniformly and attains a speed. Attains means got to or reached, are you following right? A speed of 80 meters per second. So I'm going to start the motion from here. So let me just draw something like this. It accelerates uniformly. So this is uniform acceleration. I'm going to stop over here. So taking this thing to the vertical, the uniform acceleration took the vehicle to, or the car to a speed of 80 meters per second. Now, it maintains this speed for another 30 seconds. But take note that when it attained a speed of 80 meters per second, the time is 30 seconds. So if I trace this thing down, if I trace it down, the time here will be 30 seconds. Alright, now it maintains this steady speed for another 30 seconds. This speed of 80 meters per second, it maintained it for another 30. So let me go this way. Since it maintained it, we go horizontally. There will be no change for another 30 seconds. That another 30 seconds, I'll bring it down to get the time. The speed 80 meters per second is constant. It maintained it. And then coming down 30 seconds again. That 30 seconds, if I like, I'll put 60 there. Okay, but let me just record 30. Later we can add up to get a total time based on the question, how long did the car travel? Now, it then slows down uniformly. So from here, after maintaining that 80 meters per second speed for another 30 seconds, the car now slows down uniformly until it comes to rest in the next 40 seconds. So from here, I'm going to draw down something like this. This is slow down motion, retardation, for another 40 seconds. So let me place 40 here, 40 seconds. This is the velocity time graph of the car. This is the motion described. Is that clear? Alright, we are done with the first part. The second part said that from the graph, we should obtain the uniform acceleration during the first stage of the journey. Permit me to label, let this be A, point A, let this be point B, let this be point C. Okay, C. Let me call here point D. Alright, let me call it point D. Let me call here point E, and then this as F. You can label it with anything you like, it's a choice. So, during the first stage of the journey, that's from here to here. Uniform acceleration. Uniform acceleration. That's what it is. And that's what the second part of the question says we should find. So I will move on to question B. The uniform acceleration during the first stage of the journey. Uniform acceleration. Acceleration during the first stage of the journey. The first stage of the journey during the first stage. During the first stage of the journey. Stage of the journey. Alright. During the first stage of the journey. So let us see what this would be. that will be equal to the slope of the line, AD. This is equal to slope of line AD or DA, however you choose to call it. That is this line. And how do we get the slope? You know, we're going to do something like this. That is the change in velocity over change in time. This is equal to AD over DE. AD over DE. Alright, this AD, it's meant to be AE rather, AE over DE. Slope, AE the vertical over DE the horizontal. So let's see what this is going to be. AE is this height. That is 80 minus 0. Then divided by DE. DE is this length. That is 30 minus 0. That's going to give us 80 over 30. The last zeros we go off. We have 8 over 3. Let's find out. 8 over 3 should give there about 2 point something. Alright, so 2.6666 approximately equal to 2.67. 2.67 meter per square second. So this is the uniform acceleration for the first stage of the journey. Let's move on to the third part of the question, the retardation during the last stage of the journey, that is negative acceleration. Retardation during the last stage. During the last stage of the journey. The last stage of the journey. So let us look at our graph and see where the retardation occurs. So this is uniform retardation. This is the retardation point or the retardation line. It's the same as negative acceleration, where the motion slows down. And that is equal to this slope of line BC. This is equal to slope of line BC. How do we get the slope of line BC? If you take the slope this way, so it's going to be BF over FC. BF over FC. Remember, all of this is simply change in velocity over change in time. Based on my label here, BF is this vertical, are you following, which is velocity. Then FC is this horizontal, which is time. So if you work in that, let us see what this would give to us. BF is this height, which is 80. So we're going to have 80 minus, that is B, minus this point 0, all over FC. FC is from here to here. And from this point to this point, what is it going to give to us? Please, you want to take note that from this point to this point, it's not 10. It's not 40 minus 30. It's because of how I drew this thing. That's why you're seeing it this way. Remember, in the first stage of the journey, it took 30 seconds. In the next stage, where it maintained this constant velocity or speed, it took another 30. That another 30 will give you this to be 60. I hope you know that, right? 60. And then the last stage of the journey, it took 40 seconds. So here will be 100. In fact, let me use blue marker to show that below here. This is 30 seconds. From here to here is 60 seconds. From here to here is 100 seconds. Alright, so from the beginning down to the end is 100 seconds. From this point to this point is 30. From here to here is another 30, making it 60. From here to here is 40, making it 100. Which means if I am doing FC, FC is actually 100 minus 60. 100 minus what? 60, which will give you 40. The 40 seconds that was mentioned in the question. So if I want to use the time difference, it's going to be 100 minus 60, or you can simply say 80 over 40. 80 over 40, because from here to here it took 40 seconds. Now if you work this out, this is going to give us 2. The retardation is going to give us 2. This 80 minus 0 is supposed to be 0 minus 80, because this is the final point, which is at the 0 level, okay? It's supposed to be 0 minus 80, please. I explained that when I was talking about velocity time graph. Final velocity minus initial. Remember, the car slows down from point B down here. So this is where the car is like in a motion coming down. So it's decreasing. This is the initial, this is the final. The final velocity on taking the slope. The final velocity is 0. The initial velocity is 80. So acceleration, which is final velocity minus initial, is 0 minus 80. So this is going to give us minus 80 all over 40. And if you do that again, minus 2 meter per square seconds. Minus 2 meter per square seconds. Answer. What is the implication of the negative sign? Because I might choose not to put the negative. I may decide not to put the negative. So let me include the reason why we have negative there. Because even if I wipe the negative, there is no error. Okay? So I would say the negative sign shows retardation. Sign shows retardation. That is slowing down of acceleration. Slowing down. Okay? So you may choose not to put the minus. You commit no crime. Let me put it here. Let me say or 2 meter per second without that negative. You don't really need a negative if you don't want to put it. Then the D part. We are asked how long did the car travel altogether? That is time. Total time taken. Total time taken. Total time taken for the journey. Taken for the journey. So let's see what the total time will be. This is equal to, remember the first stage of the journey is 30 seconds. So it's going to be 30 plus, the second stage is another 30, and then the last stage is 40. If you add up this is going to give us 100 seconds. 100 seconds. And so that is the total time. That is how long the journey took. And we're done with this question. Alright, but before I leave, let me just ask, what if we're asked to calculate the total distance covered? The total distance covered. Just as a rough work here, let me just say that the total distance covered, x total, will be the distance here plus distance here plus distance here. Or you simply use your area of trapezium, okay? Area of trapezium, the choice is yours. I would like to use area of trapezium because if we're asked to find total distance, I'll just look at the shape. This is a trapezium. So it's going to be 1 over 2. I will add the parallel side. That's the length AB. I will add it to the length DC. DC and then multiply by the height. Let me use the height AE. Height AE. So that's going to give us 1 over 2. Sum of the parallel side AB. If you look at it, look at this part. AB, which is from 30 to 60. So the length AB is 30, as 30 seconds. Add it to DC, that is from here to here. You know that from this beginning D to the last point, the time there is 100. Alright, so this is going to be 100. Then I'm going to multiply it by the height. And the height is this 80 meter per second. So you have this. If you work this out, you have 1 over 2 times 130. 30 plus 100 is 130, multiplied by 80. So let us see what this is going to give to us. 130 times 80 divided by 2. So this gives you total distance. Total distance now, S total is equal to 5,200 meters. So you take note of this, okay? In case you're asked to find the total distance, let me just put this somewhere. Is that okay? Now, you may still get the same result by taking the area of this triangle, the area of this triangle, and the area of this triangle, and then you add up. I will still press that and tell you what this is going to be. Area of this triangle is half base times height. Let me work it out and see. Half base times height is 1 over 2, alright? I'm multiplying it by the base. That is from 0 to 30, which is 30 seconds. Then times the height. The height is 80. If you do this, this is 1,200 meters. The distance here is 1,200 meters. That's the distance. And then, okay, let me say S equal to, distance equal to. Then come to that of the second stage of the journey. That's from A to B. The shape there is a rectangle. The shape is a rectangle. So I can get this S1. S2, I can get the distance. That is length times breadth. The length is from this to this. If you check it, that is 30, 60 minus 30 give us 30. Then you multiply by the height, which is 80. If you do that, this is 2,400. So 2,400. Going to use 2,400 meters. Then the last distance there, that's the last stage of the journey, S3. If you work it out, let's see. That is a triangle, so it's half base times height. 1/2 times the base. The base is from this to this point, which is from 60 to 100. If you do this difference, you get this 40. So the base is 40, and then I'll multiply by the height, which is 80. This gave me 1,600. 1,600 meters. Now let us add the three distances and see what we get. Please permit me to use blue marker here. 1,200. 1,200. Okay, so S1 is equal to 1,200 meters. So let's see what it gives to us. I want to believe you are adding yours. 1,200 meters. Okay, so 1,200 plus 2,400 plus 1,600. So it gave me a total of 5,200, which is the same as this. And that is how we work on velocity time graph.